Hello everyone. So I've been working on a few things in Rust. Right now what I've been working on is a sorting algorithm, at least actually 4 sorting algorithms. We have the selection sort, bubble sort, counting sort, and timsort, at least my implementation of timsort from what I got from reading the description of timsort off of a website. So it was pretty good. I really don't know much about Rust, and so this was a huge eye-opening experience on what Rust is, what you're expected to know in Rust, what you do. I'm not even fully done formatting the file yet, as you can see, but so there's some things that were really interesting, like usizes. I never really had a concept of usizes before because you could usually just use ints to go through an array and index it, but in Rust you need usizes, and so getting used to that was a little weird. Borrowing with the ampersand and the asterisk is a little different, and wasn't really totally sure how I did all this at first and how I was supposed to do it, but if I go here, I ended up, there's a clone function, and so you're not borrowing the values anymore, you just clone them into their own space. And so that made it work, and now it works pretty well. I will give you guys a run. I did not print out the results of every single sorting algorithm because then there's just a whole wall of text. Like, this is just from one. So right now I am sorting 4,096 numbers, and when they get the numbers, they're just randomly placed in. I have a generate random list right here, just for as long as I want the list, in this case 4,096, I generate, either a number between 0 and 10, so that would be 1 to 9, I believe, or 0 to 9. Yeah, and that's how I get the list, and so it's a big old random list. Selection sort, it'll just go through the whole list and then grabs the lowest one. Okay, and then it'll like, alright, I'm not going to sort this part of the list anymore, it's already sorted, goes through the rest, does that again, grabs the rest, and it does that until it's completely finished. So it's not very optimized at all. It takes quite a while, actually, compared to timsort, and then counting sort especially. I actually disabled counting sort. Let me run this again, but with counting sort so we can see how quick that one is. Let me see, okay, counting, there it is. Okay, let's try this one more time. Come on, there you go. Okay, so yeah, look at counting sort. 432 microseconds. That's not even milliseconds, that's microseconds. So that's like incredibly fast. But the problem with the implementation I have of counting sort is it can only do numbers 0 through 9. So if you needed to do numbers higher than that, it won't work. That's why I had it disabled. Okay, and then, oh yeah, bubble sort. So bubble sort's like, just goes between like left or this number and the number to its right. And if the number to its right is bigger, then it'll move it back. And then it'll check again, and then it'll move it back. And so it's really slow because it can go through this list, thousands of times, theoretically. And so it's really slow. You would really never want to use bubble sort. It's just easy to implement, and so that's why there's even examples of it. And timsort splits up the array. So right now I have it chunking in 32. So it grabs the first 32 of the random array, sorts it from 1 to 32, all the elements using a selection sort, I believe, and then merges all the arrays back together. And so that's basically what I got. Rust is really interesting. I've never really had to think about my code that much before, Like, you really have to think about what you're doing and how you're doing it. And I think that's a huge benefit, though, for Rust, for sure. Alright, thank you guys for watching. Have a good one.